Shut up and sit down.
Good morning, everybody. Welcome to my latest stream, KiteCraft, live coding on the ESP32. Working on my latest project called HardSense. You can see it up here in the top corner. It is a small little microcontroller with a little display, which happens to be a touchscreen, and it's displaying a real-time stream of information from my desktop computer. In this case, it's a big thing that sits on the floor. There's two parts to HardSense. There's the part that runs on the microcontroller and forms this little box up here, and you can kind of see an overall view of it. If I reach around, you get a better idea of the scale of what's happening with the camera that's in the middle. That one. Sure, that one. And then, of course, my begging screen down there at the very bottom. And you'll hear me begging a lot because I'm using VS Code for doing all of the Arduino development on the ESP32. And that's what I'll be working on today. There is, in fact, a second component to this, which is a Windows application. And it is also called HardSense. But this one runs as a tray application on the Windows, on my Windows machine, or your Windows machine. And, pardon me, it reads all of the computer sensors that are available, in this case 71 sensors. Now if you're a returning viewer, you're going to notice that's a different number again, and yeah, it does. I don't really know why Windows gives me access to certain sensors at certain times. It's a permission weirdness going on, but for a while yesterday it was 76 sensors available, and I haven't bothered to actually look to see which ones are coming and going, because all of the core ones are in fact here most of the time. Well, what I was saying is that this program will actually read all of those sensors. It sets up a monitor and records all of this data into a memory mapped file where it's actually being updated 4 times a second. So it sets up that little monitor. It's in its own thread. It's doing its own happy little thing. It also kicks off a second thread, which is a TCP server, which you can connect to as a client, and it'll kick off a little thread and go on its merry way. And your client can actually now request a list of sensors by device, or it can request a list of specific IDs, and these will be sensors that are actually streamed back. And that's what we're seeing up here. This is the HardSenseESP32 itself. Now you'll notice there's some weirdness going on with the fonts, and that's okay, I'll explain that later. But here's the ESP32 if I stick my finger in there. So that's the whole microcontroller. Whoops, I got a transition. Right here's the microcontroller. The display is only about 2.8 inches across. In fact, you can see my finger on it. Now this is a full touchscreen display, and what we're working on is actually streaming all of the sensor data. The screen we're seeing right here is the Bluetooth Configurator screen. So I can actually connect to it. If we come back to the desktop, in this Windows application, if I go to Settings, Bluetooth Configurator, the ESP32 is connected to the computer through a standard Bluetooth pairing, and it shows up actually as a device called HardSense. Where'd it go? There it is. In this case, HardSense ESP1, because that's what I paired it as, and I haven't repaired it since. And all of that can actually be, once it's been paired, you can go ahead and connect directly to it. And this is all of the information that we have about that device. Now it's actually using the Bluetooth device ID of ESP. So if I were to disconnect or unpair it from my computer and then go through the whole pairing process again, it should show up as HardSense ESP. So what we're actually working on today is over-the-air updates to this whole thing, because there's actually a lot more going on. If I exit this, we're going to go ahead and focus on this, and we'll just reboot this into normal mode. Now it's going to reboot the system into normal mode. This is the splash screen, and here we are. So this is what I call the home screen. On this particular screen, we actually see that we're streaming a lot of basic sensor information from the computer, including the CPU's load, its temperature, its overall wattage, as well as its megahertz, as well as its clock speed. Now this is normally information you could see if you had Task Manager up, but now it's actually being streamed to a little device, as you can see from the various screens. It's about that big. There's a GPU panel, which is again displaying information specific to my video card, in this case an NVIDIA GTX. What the heck is it? An EVGA here. Well, you know what? If I can't remember what it is, what I can do is I can actually just touch on that, and it goes to my game screen. Oh, okay, so my video card is actually the NVIDIA GeForce GTX 1080 Ti. Well, that's a mouthful. So yeah, this is a full touchscreen, and it's capable of delivering multiple screens of information. On this game screen, we can see a 90-second graph. We're actually displaying the temperature and the fan speed, because as a gamer, that's information I'm actually curious about. We also have the clock speeds for the GPU, and up in the top corner, this bit right here, that's not the system RAM, that's the video card RAM, because that's what's important on the video card. And then of course we have the clock, the overall core speed of the GPU at that particular moment. And net speeds is always important to know. Now the bottom corner of all of the screens except for the home screen, this bottom right corner is always my home button. That's actually built, oops, there we go. That's actually built into the base class. So any new classes that I build, I don't have to actually worry about that. It just happens. More or less. Actually, I think I do have to add the touch handler bit. Yeah. Anyways, we can actually also go to the CPU panel. We can have a look at the CPU details. Now remember, all of this is going to sit in a little box about this size. You can see my hand on this little box in the bottom corner. Hello, way over here. See on the right side of your screen? Now, this screen will fit into this box. We haven't designed it yet. That's actually coming up. Part of the end of this project is designing the circuit board that all of this stuff will fit onto, as well as the box that it's all going to go into. And then that'll be the final bit of this project. An important step of getting there is allowing over-the-air updates. So instead of having to plug in the USB cable every time I want to update it, I would normally have to plug in this USB cable. You can see it right down here. I hope you can hear me okay. Let me just see. Yeah, okay. I hope you all can hear me okay. So from those updates, what we're going to do today is we're going to actually give it the ability to accept its new firmware updates over a Wi-Fi connection without a USB cable. Once we've achieved that particular goal, we can now do everything wirelessly, and this thing will actually just live in a box built running on a battery, and I can do all of the firmware updates just by running it into the Bluetooth configurator screen and saying, give me an update over the Bluetooth or Wi-Fi, I mean. And it'll be awesome to do, but there's a few steps we actually have to take in the process. Now, you might notice that my little buddy over there, Sergeant Renfrew, has gotten involved. I want to show you something really interesting that's going on. I'm going to go back to my Bluetooth configurator screen. Now, Sergeant Renfrew over there, the moose, he's my parachuting moose. He's part of the RCMP, Royal Canadian Moose Paratroopers. He is actually wearing a parachute. I take him kiting with me, and he drops from parachutes. Anyways, he wanted to get involved, so yesterday he was holding this little toy oscilloscope, and I had it plugged into just, if we look at the bottom here, I had the oscilloscope just plugged into the power rails down here, so that when I actually had the power on, right here, delivering 3.3 volts to run the whole system, then the oscilloscope screen, way over there, would go high, and when this is actually powered off, it would go low. Really basic system. You know, it's just a toy oscilloscope. I don't really expect much from it. But you know what? It wasn't enough. I actually wanted to try something a little bit different just to see what's going on today. So you'll notice if you look at the screen right now, it's pretty much just a horizontal line with that little bit of a dip in it. I've actually connected the oscilloscope today to not just to the ground, right here, This is the ground for the oscilloscope. It's actually going off to the wires. And then you can see the final connection is actually being made somewhere down here. Oh, you can't see it because it's behind that one. There's a lot going on there. Anyways, you'll have to trust me, I guess. Move this back into position. Now, the reason why we're seeing one dip on that oscilloscope on this screen is this. It's connected to the CS pin of the display. Now, this is using an SPI interface. The TFT driver is using an SPI interface. Now, a lot of these definitions aren't really for the actual beginner. If you're a beginner of our Arduino, you might have to pause this once in a while and look up what I mean by some of these. Pardon me. But the SPI interface uses your chip select key, switch, or pin, however you want to look at it. And so when the SPI wants to talk to a specific device on that bus, as you know, it will pull that pin low, apparently. Or it could be, I could have that screen backwards. I don't know what's going on. But anyways, what's going to happen is now that device knows that the information coming across the SPI bus is meant for that particular device. And this allows you to have multiple devices on a single SPI bus, because the device that's doing all the talking can just pull whatever pin low on whichever device is on that device, or whichever bus is on that device. Whichever device is on the bus. Sorry, you know what I mean. See, I'm getting too much into the basics and I didn't want to do that. But my point is this. What I'm hooking up here on the CS pin is this screen is actually only updating once a second. None of this information that's on the screen is being updated. It's only this little clock up here that's being updated once a second. That's why we're seeing this very regular heartbeat on the output screen on that CS pin, because the TFT driver is literally just updating this little bit of the display once, right there, once every second. So if we were to examine the output on that oscilloscope down there, we would see it's being updated at that interval. Now, if we change the screen, now if you keep an eye on that oscilloscope down there, you'll notice that, whoops, there's a lot more going on the home screen. Some more updates. So this is all on the chip select being pulled and up and low, up and down in order for the microcontroller to talk to the display. We'll see it's a little more activity, but there is still that regular heartbeat in that same spot all the time, because this clock right here still exists and it's still updating at the same frequency, and that's causing that very regular heartbeat right on that left side. All of the other spikes of data are like that. There's actually all the other little bits being updated. There's a lot of little information being updated all the time throughout all these little panels. So anyways, I'm talking too much. Let's get back onto track. That's the oscilloscope keeping an eye on the updates for me. It's actually really cool. Let's pop into the game screen. Whoops. There we go. And we'll see that there is no clock on this screen. This is actually updating at a slightly different interval, but there is still some regular information being sent, and that's on the graph. The graph itself is actually collecting information, but there's so much in order to keep both the fan and temperatures in sync on this little display, on this little graph. It actually updates that graph on a regular interval. I think maybe 10 times a second is what we're doing. But you'll notice it actually disappears once in a while. So there's some neat stuff going on with that display. But for now, what I really need to do is find out why things are beeping for me. We're going to go on to adding the ability to update the firmware on this device without connecting a USB cable to it. You'll notice that there is still, in fact, a USB cable connected to this right here. I don't want to do that anymore. We are at the final step where after this, the next step is to go into finishing the circuit board. Here's actually an image of our circuit board that I'm designing for this particular project. We can see it. In the black bit in the middle, it's a poor picture, sorry. The black bit in the middle is actually the ESP32. Here's some header pins for connecting to the display. And you'll actually notice all of these pins are associated directly with what we see on the microcontroller. If you were to look at it, there's the pins for the encoder, the pins for the button connection, which is, I think, one of these over here. And then there's also pins for the real-time clock, which are somewhere over here, real-time clock. If you look on the bottom of the screen, we'll see that by the mounting hole is RTC. So this is the next step is finalizing this circuit board. But I don't really want to do that until I have a trustworthy way of being able to update the firmware without being able to access that USB port. Because once the circuit board is made, it goes into a box, which is, like I said, about this big. So yeah, lots going on. The fun bit, we are working with, there we go. Let's get this back into play. Oh, there's also a bug that I have to figure out that I introduced in the last stream. So if you wanted to look at what's going on, we can go to my GitHub repository in HardSense. Here it is, it's called HardSense. It's github.com, kitecraft, HardSense. We are actually working on branch 18, adding OTA. Now you'll see there's a couple of new files. If we go into software, ESP32, I've added a few files. There's now this one, HardSenseESP partition, and I've added some new information to the README file. I haven't actually done this before. This is going to be a bit fun. I started having a look at what's going on before, but in order to add a new partition, or in order to add the OTA over the air, we need to modify the whole partition. Again, what am I talking about? So even if you're in Arduino, or if you're using VS Code, which I'm using over here, I'd rather be using Visual Micro, but I'm going to try and stop complaining about that. Visual Micro, I'm going to complain about it a little bit. If you're watching this, I would normally be using Visual Micro for doing my Arduino development, but they recently, a little while ago, changed the licensing. So now they don't have the free version, which was a pared down version, and now their new version is you only get the 30-day trial, and then you have to pay for the license, and it's well worth paying for it. It's about $26 or $27 Canadian to buy that license. And Visual Micro, which is an extension for Visual Studio, and you can do all of your Arduino development or other IoT development in there. And it is a wonderful, because it has an excellent little easy to use debugger. It's built into Visual Studio, so you can meld it with your other projects and have very easy of access with your Git repositories. It's branching management, all that. It's wonderful. But I can't use it anymore because I can't afford the license. The license, like I said, is about $26, $27, and that's about $140 more than I can afford to spend. So if you look way down, all the way down at the bottom, and my little bug there, you'll notice there's a couple of me begging for some money. That's what I really want to do, is I want to upgrade to some better cameras. I also want to get a license back for Visual Micro so I can actually do some better development, and we can get on with some of these projects a little easier. You'll see that using VS Code for this Arduino development is very slow. The compile time and upload time is ridiculously slow, and it's a pain in the neck. Anyways, so we are working on that particular branch. Now, what I've been working on so far, and it even mentions in the existing README in the master branch, what you'll notice is it says, where to go? Let's go back to master, and we'll go up to the top here. It even says, come on. To build HardSenseESP, you need to change the partition scheme. In the tools configuration, use huge app. And that's what I've been using so far to do all the development. So if we look at the traditional Arduino, we go to tools, you got your partition scheme. This is what's wonderful about the ESP32, along with its Wi-Fi and Bluetooth and huge amount of pins and the file system and all of these other wonderful things, and its massive size and its dual cores and all of these. It's just, you know, it is such a wonderful little SoC right here. I just love it. It does everything. We can change how it uses all of that available space. So up until now, I've actually just been building it with this absolutely huge space for the program that we're building with the code, so I don't have to be too stingy with it. And then a rather large SPIFFS file system. Again, I don't have to be too stingy with what I was doing with the font files, and I could just have a lot of freedom because I knew both of those numbers are huge. I'm never going to hit those two numbers with what I was doing. But now I've built my application and I have a really good idea of how much space I want to use going forward, and it's really small with adding the new classes for the screens. They're so small with the display handler, so I can actually I don't need hundreds of hundreds of kilobytes to add a whole many screens. I actually only need like 100 kilobytes to add some screens. And the SPIFFS file system, 1 megabyte, I actually only need about 250 kilobytes in order to satisfy all of my font files. If we have a look here, recent, where is it? HardSense. Now if we have a look at its little file, we go to what, Control K? Yeah. So you look at its data folder. These are all the files that are going into the SPIFFS file system, plus there's also a tiny little file which is a data calibration file that the touchscreen controller uses, the touchscreen handler, which was built by Bodmer. There's links to it everywhere. And let me have a drink. There's also no, I think that's it. But it comes out to about 170K or something when it's all said and done, and I really don't need a lot of space. So I'm pretty sure I can actually stuff in an OTA partition in here and get away with more than enough space for both a SPIFFS, all of the fonts I'm using. Even if I want to add a new font, I might be able to tweak it till it's big enough, but I'm not going to worry about that. And more than enough space for the program space, because what we've noticed when we do the build, if we have a look at how big it is to build this program, where are you, line? Choosing baud rate. You're around here somewhere. There you are. Sketch uses 1.38 megabytes of storage space. So using the huge app partition, the one that I was just showing you, if we go to the board config in VS Code, it's this thing right here, huge app, 3 megabytes. So my program is using just under half of the available program space. And I already know that the files I'm using are taking up less than half of the available SPIFFS system. So let's take advantage of that. So what can we do about it? I'll show you what we can do about it. Where's my file? I lost my README file. Hang on, for some reason, that file. You know, VS Code closes things on me. It does. I don't like VS Code. It's very annoying. It makes me sad. Where's the other file? Anyways. Okay, well, whatever. I have it stored in a notepad. What we're looking at here is options. Sorry, I want to catch up to where I am. If we look at it, some options for this partition screen, just what's built into the system. We can have a look at what we can see. You know, default 4 megabytes. No. Minimal. So that's an interesting system right there. 1.3 and a 700K SPIFF. Well, that's pretty close to what I want. No OTA. No. Huge app. Minimal SPIFFs. 1.9 with OTA. And 190 kilobyte SPIFFs, 16. So that's a really interesting one, this minimal SPIFFs. And that's the one I want to use as a template. So if we look in our new file system, or in our new, we're going to see software, ESP32. We go to our branch. There's this new HardSense ESP partition. This is actually a copy of that partition that I just showed you. Tools, partition scheme. This minimal SPIFFS. What I've done is I've actually copied that raw CSV file and I've copied it to this directory and I just renamed it. This is my starting point because that is almost exactly what I want to do, but not quite. I've actually tried using this and the SPIFFS file system won't quite compile because the overall files that I'm using are just over like about 178 kilobytes when it's all said and done with the data calibration files and whatever else happens. So it's not quite big enough, and the SPIFFS application, the application part 1.9, I can actually deal with making that smaller by like 100K. So I'm going to go ahead and try and use this one as a base and just tweak these numbers a bit for an overall partition scheme that's going to fit me. Now you can find these partition schemes in, assuming you've just gone ahead and you've done all the basic default installations of Arduino and the ESP32 add-ons, which you've probably done. You know, there's no use changing anything. You'll find all of those partitions in this little folder. Now, it bugs me that everything is hidden in this app directory folder. You know, it's just such a cruddy folder to use. I could wish I could choose that and just, you know, I don't know, but it's always, anyways, I'm going to quit complaining. There's a history there for me. Anyways, you drill down all the way down, all the way down, all the way down. Eventually you get to this directory. And inside this directory, you're going to see a whole bunch of little SPIFFS file or little CSV files. And each one of those CSV files aligns with one of the options in this partition scheme. And that's controlled by a file called boards.txt. So I'm talking about all of this. Now here, I'm going to stop talking about that. There's a couple of links right in the bottom of here, and they're going to take you to these two pages. Go ahead and read these pages. I am also using these two pages to learn how to do this. I've never actually built my own partition scheme, so welcome along. If you actually know what you're doing, please feel free to talk. Otherwise, these links are where I'm also getting my information. Now, I've already gone ahead and done a little bit of messing around, got an idea of what I'm doing, but I haven't actually tried committing anything yet. So we have, this one will actually just sort of give you the information I was just talking about, how we actually, what directories they're in, kind of what this information really means, how we actually add them back using that boot.boards.txt file, and that sort of information. And here we have a little bit more about basic OTA programming, over the air programming, which is the second half of what I need to do after we get our, after I get the partition size working properly. This is what I'll simply use as my starting point for adding OTA into HardSense. It's not going to work exactly like it is in this tutorial, but it'll be similar to it. Now, interesting, I'm pretty sure I have a bug somewhere in HardSenseESP, but I notice it's been running on this screen for quite a while now, and it hasn't crashed. I know it hasn't crashed because if it crashed, it would have been on the home screen by now. So, if you look at, I've been messing with trying to fix this bug, but I don't know what's going on. If we look at our game screen in the constructor, I was actually adding some checks on the free heap here, and I discovered that there is, in fact, I've introduced a memory leak, and it seems to be coming from the net panel. Now, the net panel is something I'm reusing on that Bluetooth configurator screen, which is where I've actually done all the work, and I think I did something bad there to the net panel, or sorry, to the time panel. Anyways, sometimes it's crashing, sometimes it's not. I don't know why, but I think I introduced a memory leak. Sorry, I've been fighting this cold, and I've got tea, and all bad things are still happening. So we are trying to build a new partition scheme. So I've taken the default partition scheme, I've renamed it to HardSenseESP. Now this is that 1.9 megabytes of app space and 190 kilobytes of SPIFFS with an OTA. Now, if we look at what's going on here, I'm going to compare it with the huge app. This partition scheme that I just pulled up is the one that I have been using. I'm going to go ahead and copy it. Go back to my new partition scheme. This is the partition scheme that I want to base it on. It's that minimum partition scheme, sorry. Now don't worry about pasting it in there. This is actually just for some comparison, just so I know what's going on. This is the one I want to use, this is the one I have been using. So these first two lines seem to be identical. Right? NVS, data, NVS 09, yep. OTA data, don't worry about it, it's there. Now this is the big one that I've been using, and so you'll notice that this app 0 space is huge, and then we go straight to a SPIFFS. But up here, we have our app 0 space, which is actually smaller, and then we have an app 1 space, which is about the same size. And then our SPIFFS space has actually been reduced, because here's our starting space for SPIFFS and our size, and SPIFFS is now starting at a much different spot and is smaller. So we don't need these first two lines. They're similar in each one. But what's going on here? So what I want to do is I want to make this smaller. I want to keep the starting point here, but I want to make its size a bit smaller. And then I need app 1 to start immediately after this new size, which means this number is going to go smaller because of that. I want to keep this size the same. This is my OTA space, so I want to keep that size the same. This isn't going to change. And then the SPIFFS, I need to make it a little bit bigger. So that's my goals here. Now, you can't just throw new numbers in here willy-nilly. They have to be incremented in a specific size. I don't know what the hell that is, though. This is where I have finished, and this is where I'm learning what's going on here. So, read with me here. Where is it? Yeah. No. Somewhere around here it explains exactly what sort of increments and how to do that. Oh, here it is. The main SPIFFS has two partitions. So using a hex to decimal, we can get the size of it, right? Can I just change those numbers? Well, you know what? The cool thing is I'm not going to upload this, and it's not going to blow up my computer or blow up my brick, my ESP. I can actually just use this as a bit of a test just to see what's going on. So, first of all, I'm going to back this up, and I'm just going to keep this as a copy somewhere so I can always come back to it. Now, I think I actually need to, first of all, I'm just going to take this system and I'm going to add it to my boards.txt and actually make it show up in here. I haven't changed anything about it. It's still a copy of the system, but first of all, I need it to even show up in here. So there's no use changing anything until it shows up in here. So let's make it show up in there. Where's my readme.txt? So the file boards.txt is also important. So I need to go to this folder and open that file. Hello, Steam. Oh, Steam is having an interesting event. The American Truck Simulator event. This is cool. Happy Valentine's Day, everybody. Forgot it was even that. Anyways, so boards data. Let's open this file up. Hang on, I just got to get there, change the ID. There we go. So that's the boards.txt file. Let's go ahead and bring that in here. We're just going to go ahead and edit it. Now, this is the bit that I was talking about. This adds the partition scheme to that menu item. So if we go back to my readme.txt, I'm just going to take the bit that I've already written here. Now, all I've done is I've changed the name of it, but I haven't actually changed any of the other values yet. This is still the default. So I'm just going to take this text and I am going to paste it into the boards.txt file right at the very bottom. It's called HardSense. Everything in there is called the naming scheme, and I'm going to save it. Now I'm going to take my actual HardSense CSV file and make a copy of it somewhere. Where the heck do I have to make a copy of it now? Where's my README file? So the CSV file now has to go somewhere deep. So I was just here, 104 boards. Now I got to go into 104 tools, partitions, and there they are. There's a little bit of work to all of this, isn't there? So, but it pays off. It pays off because all I have to do now, we're almost there. Just take all of your instances of Arduino and close them and restart it. Let it go, let it go, let it go. Toss a coin to your streamer, oh valley of plenty. Whoa, whoa, whoa. Now, with a little bit of luck, tools, partition scheme, HardSenseESP. There we go. Now, that should also mean that I can now, I wonder if I have to restart this or if it'll just pick it up. No, looks like I also have to restart here. All right, fine. Be that way. Okay, so that's restarted. Now let's pop back into here and see if it shows up now. Come on, please be here. HardSenseESP. What a win. What a win. So those now this is all instructions pulled off of that web page, so that's a win. Now let's go ahead and compile this. This should compile fine and we'll be good. But I'll show you a problem after I compile this. So we'll go back to the home. Up in the top right corner, we're just going to go to verify. Now, while that's verifying, you can see the output being on the bottom. Auto scrolling is on. Let's just pop over to here. You can see it's still running. The oscilloscope is still giving me some interesting information there. Let's pop over to the home screen. There we go. So if it crashes and restarts, you notice it and I don't, please say something in the chat. Okay, so this is still building way over here. It's going to take a little time. VS Code is so slow in its building. It really is. Microsoft using Visual Micro with the Visual Studio extension. You know, there's so many. Oh, look at that! Just pinned my CPU. That's the compiling bits of this program. Wow. Look at that, eh? You know what? Let's see. So that's Task Manager I just opened up. And if I got on HardSense, if I go to my CPU screen, oh, it's a little hard to see. exactly what's happening there with the graph. This is a little odd graph, but we can see what's going on. This is showing the individual threads, so that's why there's 1, 2, 3, 4, there's 12. Whereas my display over here on HardSense is actually showing cores. That's why there's only 6 of them on my displays, because this is a hyper-threaded hex core. So my display is showing information by core. We can see up in the top we have the full package, power usage by wattage, and the core's usage by wattage, the overall temperature of the package, and the package total load. And then they get split down into the actual individual cores. And each core has its own clock speed, individual temperature sensors, and usage. And you can see that we're using a lot of stuff with the OBS streaming that I'm doing, the compiling and everything. But it does pretty much line up. Well, it does in fact line up with, you can see now that we've got some data streaming there. This is, Task Manager. That's real streaming data, baby. I ain't kidding. We'll have a look at our GPU. Yeah, same. Let's pop over to our GPU. We'll go home on here. Come on. And then onto our game screen. So remember, the graph is actually only the temperature and the fan, not the usage. I don't have a usage chart. That would be interesting. But yeah, so we're really golden with all the information there. And the OTA, the new partition scheme I used, well, it compiled. It didn't give me any errors. Let's have a look at what it said here. Sketch uses, it's the same compile size, 70% of program space. See that number? That's an interesting number, isn't it? Let's go have a look at that number. If we open up the partition file, this is my new program space, right? And this is the size. So if we take that, and let's see here, we go to here, we want to convert hexadecimal into decimal. Now let's just take that number, this number right here. This is the size of the program space in my new HardSense partition scheme. Let's go verify it, convert it. 1966080. 1966080. So what do you know? Here's what I want to know. I want to know how to change this now. I want to make it smaller. What if I make it, I have a copy of this so I can mess with this. What if I do this? What if I make it CD? I want to make something noticeable, right? What? If I think that's too small, here's, whoops. Whoops. Yeah, I'm going to change it to this. Whoops, B. Why do I have my caps lock on, for crying out loud? Okay, let's just have a quick little check of something. We're going to go convert that. 176, eh? So that's what it was. That what it would be, and my actual usage is this. So actual compiled is 138. Now I know I want to add some screens. I'm going to do some print stuff. Plus there has to be some just buffer space for, whatever. So 76, 80, so that's only 20K. Let's go with, sorry, that's 200K. I think that's a good change. Let's go with that. Here's why. Oh, I was going to show you why I have to do this. Why can't I just use this partition scheme as it is? So I've reopened HardSenseESP in the Arduino. I can't seem to do this in VS Code. It's really annoying. We're going to go here, make sure that I've picked the same partition scheme. Now remember, this is the default partition scheme. I haven't changed it. It's the same as if I had picked this one, minimal SPIFFS. Right? It's the exact same CSV file. I haven't edited it yet. I've maybe edited this one, but this is actually this is the copy that's in my local repository. It's not the one that's actually in the Arduino's compile path. So this one's safe. I can do whatever I want to this. It's not changing it. But here's what's going to happen. Let's have a look at the file system. Right now I've only got these in here. But let's see if we can actually do this. We'll do the sketch data upload, and you'll see SPIFFS failed to create. File system is full. There's just not quite enough. Because this is only 190, and there's actually 170 total data that's going to be used, there's just not enough. So I need to make SPIFFS bigger. That's why we're doing this whole exercise. Okay, so what I was doing was I was changing that from 1E to 1B. So now I need to move this to where? No. 1C? Now, oh, it crashed, didn't it? Damn it. I didn't have my output set up. So something is going on with my display there. I don't know why. It's an interesting bug that I've introduced I got to deal with. Okay, so now I want to keep that same size, don't I? Which means moving this down to what was the original value? Whoops. One E, so 1F, 1E, B, so 3. I think I want to keep that the same size. You know what? I'm not entirely sure. Hang on. Something about the way that works. Partition table. I don't remember if it's the overall size or if it's the endpoint. So it says offset, so that's the starting point. Now size. Yeah, that is the actual size, okay. So D, yeah, EF, yeah, okay. So I should be able to just move this number down to, where am I going with that? Yeah. Yep, that should actually, you know, that might work. So let's see. Well, I got to change this. I think that's what I got to do. Let's have a look at this number. Yeah, so my SPIFFS is now 208 kilobytes, or 208 bytes, which is good. That gives me exactly the buffer. I think that should work. Now we come back to that partition scheme, and yeah, this should work. So what I need to do now, this is the tools partition directory. I need to copy it in there. I've saved this, right? I've saved it. Yes, it's saved. So I'm going to copy this into here. So that's got the new partition file. Now, let's have a look. I'm going to copy this line right here. Into my, to my temp readme. This was the original, right? Original from huge app partition. This is my actual compiled. This is what I just did with minimal SPIFFS. I don't need this line. Don't need that line. So compiled with minimal SPIFFS. I'm just taking notes so that I know what the heck I'm doing after I mess all this up. Because things are going to go bad, I'm sure. Compiled with. So, is this thing still cycling and crashing and doing bad things? Oops. Beautiful little system, isn't it? You gotta love it. So you can have a look at the oscilloscope is doing its thing there. I'm just modifying some code here. Okay, so what do we got going on here? Okay, so this is what I actually did. Now I've updated it with my new partition scheme. So my app data is now a bit smaller. I expect it to be where's my, so my new app data size is going to be that. Where's my my file? So I'm going to put it in here. HardSense ESP partition sizes. So program space. I'm calling it program space. I don't care if that's actually the right term or not. SPIFFS should be. What was the magic number for SPIFFS? Shout it out now before I have to figure it out myself. Yes, I know you have a 30-second delay, but you can do it. Read the future. What was I looking for? This value right here. In there. SPIFFS is now 208. So, hey, you know what? Interesting. Okay, so, hey, I gotta take this number, stick it into the boards.txt file. Right? Yeah. I'm going to have to reload everything again to make that all take effect. But let's copy that. Let's make sure I've saved this. Yeah. I've saved this. Yeah. I've got my notes taken, right? The new SPIFFS size, the new program space size, yeah, saved. Okay, first of all, let's actually just close all of this, Arduino. And then I need to take, where am I here? Right there. My local copy, paste it into the actual partitions directory, so now that's updated. and all that's beautiful. Let's get rid of that. Now let's restart Arduino to reread all of those boards.txt. It should have my new numbers in there. So why am I doing this? Because I'm going to try and compile the SPIFFS file system. But I'm not going to upload it, that's for sure. I'm going to let it just fail on that. So just to be safe, I'm going to unplug my my ESP32 because I don't want it to get updated. I just want to see if this fails like it did before. This time it should succeed. It should succeed. Tools, partition scheme is selected. I haven't set those numbers yet, but that's okay. We're just going to see if this works. Damn. Why didn't that work? Even bigger? Well, you know what? Let's go ahead and just check it with VS Code and see what that compiles to. See if those numbers make sense. But I'm going to have... Do I have to restart this? No, I shouldn't. Verify. So let's just see if we come up with different numbers for this. Yeah, it's going to take a while. I'm still suffering from this cold. This is day 3, so I'm very sorry, but I'm going to have a halls. All right, so get that to compile. Wow, it's taking forever. I really would like to start using Visual Micro again, and, but like I said, the license for that is $26, $27 Canadian a year, and that's about $140 more than I can afford to spend. But if you look down below, there's some begging text, which would help me a lot. Not just, to help me with the stream, I would like to get a Visual Micro license. I would also like to maybe get some better cameras. Doing all right there, but mostly, pay rent and eat food. Some basics, things like that. We'll see how it's going. I'm thousands of hours away from monetizing this video channel with YouTube, so I'm not there yet. So if you want to share this and tweet it out and have fun and share my channel, that'd be great. Subscribe, watch things. It's verifying. Oh my God, it is so taking forever. I really just want to see how big it compiles and what these numbers are to make sure that my partition size works. But I'm going to have to make a couple more changes to it to make it work better, apparently. Come on now, you can do it. So these are the new numbers that I came up with, which I think is right. Are they what I predicted? 176. It is exactly what I predicted. And SPIFFS should be bigger, but it's not good enough. I still have sufficient room there to change this and still not be worried about running out of space for new screens. But I need to make SPIFFS bigger. Now, did I screw up on the SPIFFS side of this? I shouldn't have, but I need to make this a bit changey again. So I'm going to drop this down to another 200. Okay, this is what it was. I'm going to make a copy of that. Just make some notes. Okay, so yeah, this is going to call it test 1, sure. Now I'm going to modify that to something new. Sorry. see what's happening on the oscilloscope. Mr. Renfrew, what's your report? Activity. Nice. Are you happy? That's cool. So that is, in fact, one of those toy oscilloscopes you can buy. And you know what? I feel bad. It is a copy. It is a ripoff. Sorry, guys. You know, you don't really know that until after you get it home and you Google it or whatnot. But yeah, sorry. But anyways, there it is. Let's go back to the home screen. Whoops. So if you're new to the stream and what's watching, what we're looking at here is down up on that left side, right over there, in Sergeant Renfrew's lab. That's a small little oscilloscope. And it is in fact connected to my project here. The ground line of the oscilloscope is connected here. Follows the wires all the way down through here, and they come back up over this way and in there. The red wire of the oscilloscope is this one right here. Can you see it? See this line right here? Whoops. Right there. Comes out of the side of this. So that wire comes all the way over here, and if you look closely, you'll notice it's actually connecting to the third pin up on the display. It is just a regular 2.8 inch display. You can buy these pretty much anywhere, it's cheap. But that third pin is the chip select pin. So what we're measuring on the oscilloscope by connecting to that CS pin, this is an SPI interface with the ESP32 and the microcontroller that's on here, using the Dft_ESPI library from Bodmer. Don't you ever get sick and tired of all of these ridiculous numbers? You know, when I'm just playing with this stuff and building it, it wasn't a big deal. But now that I'm actually, I'm trying to stream and talk about all this stuff, it is such a mouthful to say all the stupid ass numbers. Anyways, you're familiar with SPI, you're familiar with what's going on. I've connected the chip select to the CS pin on the TFT to the oscilloscope. And that's what we're seeing there, is every time an update command is sent from the microcontroller to the display, we are seeing activity on the oscilloscope. Now, if we switch screens to our Bluetooth configurator screen, so this screen only updates once a second. The only activity on this screen is that clock right there. There's no streaming data of any type to this screen. So we'll notice on the oscilloscope there's only that one regular pattern of the dip as the update is made to the screen. All of the other screens have data being streamed to them directly from the microcontroller, or sorry, directly from my computer, and so the screen is being updated as the data comes in, and that's why we see so much activity on the CS pin. Just like that. It's pretty cool, eh? Alright, so now continuing on with adding the OTA. Now we're going to take this default, or sorry, this little bit I changed, and we are going to make it a smaller app size by 200 by a 2. So the new size is 163. I'm happy with that. There. Program space. 168. 138. It's getting close. It's getting tight. I really don't think I want to go smaller than this. This really should. If this doesn't get my SPIFFS file size working, I know I'm not doing it right. This really should get everything working. Okay, so I've changed that number. So I need to move this one down to C2. to A. Keep it the same size. Move this one down to 8. And move this up to 3, 4, 5. I think. Wait. What? Wait. Yeah, I wrote it down here. Okay. So now my SPIFFS is a bit bigger. This has to work. This has to work. This has to work. Okay, so let's take this, save it. Did it crash? Okay. So the last couple of streams I added in my last couple of streams I was adding in a new Bluetooth configurator screen, that one I just showed you that was in red with just a clock on it, and a new splash screen because I wanted to update some information about what was going on. And then I updated a new option to update the device IDs remotely through the HardSense application. I haven't actually done any touching to the home screen or to the game screen, any of these existing screens. So this is the home screen that we're looking at here. All right, something's broken. So my oscilloscope has basically turned itself off. Let's turn this back on. So I haven't touched any of the home screen components or the game screen components, but I've introduced a crash somewhere. But I have messed with the serial object. So I'm thinking I've done something wrong there, and I've created a small memory leak, and that's why it's crashing. We'll get to that later. For now, I want to get this file system working, this OTA capability working. Well, the partition size compiling properly. Okay, so let's take this. Pardon my whatever. Yeah, that's interesting. Okay. So I'm going to take my partition, copy it over here, replace it. So I've got my new partition copied over, which is this one. Now, I can go ahead and compile this, and it'll show me that everything's smaller. I'm still using the same partition, so this should just work. Why does auto-scrolling turn itself off? Oh, I like Visual Micro so much better. Oh, I'm on the wrong screen. I'm sorry, I suck. Auto-scrolling turns itself off sometimes over here on the right. It's very annoying. Just trying to get this partition size. I think adding the code for the actual OTA update itself is going to be fairly easy, and I don't think it's going to take up a lot of room. But we got to get this partition size working properly. It's very important to have this working properly. So I want it to compile with the right maximum program size. With enough left over. No, I actually do have to go ahead and restart it. Let's go ahead and restart this as well, just to make all of those files take effect. I think I should update the boards.txt file as well. Yeah, while I'm here, let's make sure I updated that. Oh, shoot. Where's my board.txt? I gotta change this number to, where is my readme? I have to change that to this number. And I'm gonna put this in here. So 1 point, SPIFFS is how much? $217, call it 217, is that fair? Program space, we're going to call it 1.6, is that fair? Okay, well that's what I'm calling it, so whatever, nobody's complaining. Now, what we really want this to do is we're going to go here, have a look. HardSense 1.6, OTA 272 kilobyte. Good. Now, make sure that we're in the right directory and we have data. Okay, so there's my default config file, my 3 font files that I'm using. Good. Cross your fingers. Let's see if SPIFFS compiles. Son of a. I'm pretty sure I'm doing something wrong. That should have worked. Did those numbers change? Huh. You know what? I never noticed that those numbers were different this time than last time. So, you know what that means? Unfortunately, I have to go backwards in my experiment a little bit. I'm sorry, but that's okay. Let's go ahead and just compile this with this particular setup and get the numbers. This is what I predicted. This is what I'm actually getting. I should make a copy of this. Here. Okay, good, good, good. Now what I want to do is I just want to build this and see that that works. Come on and build me some Arduino code. Toss a coin to your streamer. Oh valley of plenty, oh valley of plenty. Toss a coin to your streamer. Oh valley of plenty. Anyways, it just takes so long to build in this VS Code. It's very annoying. All I want to do is just. It really shouldn't take this long. But I do think I have a mistake in that CSV file for the way that partition is set up. I don't think I'm doing something right. But we're going to soon find out because I'm going to run one last test because I didn't actually take note of what these numbers were last time. And that could be interesting to know. Come on. So slow. So slow. While I was doing that, I may as well go ahead and check my Twitter feed. Somebody followed me. Hey, I got another follower. Awesome. Thank you, Alessio. You're an embedded developer. Hardware, FPGA, CPU, digital, RF, FPGA, C, C++, C#, assembler, Python. You've been around the block. Yes, got that right. And my compile size hasn't changed, 138, so that's good. That's right, but I don't know about that number. So what I really need to do is I'm going to switch back to this one that I used previously and just see what that did. I want to see what these numbers were with this partition scheme. So I got to save that. I got to copy it to this folder. Now I got to restart everything again. So that it picks up the changes. Oh. Actually, I got to go back to the boards.txt and change this number. That number should be, where's my readme.txt? I'm using this one, so it's this number. There. Now let's close that just to get it all done. Now, open up Arduino again. And I'm just going to build that SPIFFS file system and hope it works. But it's not. But what are these numbers? Where'd it go? Oh, I gotta open VS Code. So that's test one. So yeah, that's good. I mean, that's right. Let's just have a look at this number. $3670016. Size 212. Yeah, that's right. Why is it full? Okay, you know what? I'm going to try something. It should be more than enough space. Alright, you know what? Let's try something else. Let's try this. I want this folder here. New folder. I'm just going to make a backup of some stuff here. Original data folder. So what I'm going to do now is I'm actually just going to remove everything except for that. See? Let's see what happens here. Okay, good. Now let's just remove those. Good. So that means it's compiling and doing the right things. What about that? Still working. What if I, now this will fail, right? But for a different reason. Yeah, okay. Get rid of this. Still too big, okay. How can it be too damn big? What's the total file size of that? That's 166 kilobytes. It should not be too big. Why? That's only 166 kilobytes. That should fit. What's the minimum SPIFFS size? No. Wait, what? That should be more than enough. SPIFFS size is 204. My files are only 166. Not these over almost 40 kilobytes. It should be more than enough. Free space. No? If I go any smaller, I'm not going to be able to build this. But let's try test number 3, and we'll just go a little bit more. We're going to change this. Okay. Right? SPIFFS. And the program space is just, it's getting crowded. I don't know now. Now it's getting worrisome about enough space to fully add the Arduino Ota code, processing code, because that's going to take up a chunk. And I might not be... Another option is there's a way I can recreate these font files and cut out some of the fonts that I'm actually not using. I think I actually took out a really big chunk. Yeah. But anyways, let's just do this last experiment. This is test 3, right? SPIFFS file size. So let's change the boards.txt to be this. Just for the sake of knowledge, I'm going to change this numbers to... Why does that say 217? Did I do something wrong here? Yeah. Oh, I went the wrong way with that number. Hang on. Okay. That should be 36. Yeah. Maybe I made a mistake doing that. Did I make a mistake doing that? I think I did. Yeah, so this should definitely be big enough now. $221. Yeah, shoot, I think I made a mistake there. Program space. Yeah, okay, good. Good. So this will, okay. So let's. Is that right? Oh, wait a minute. I screwed something right up, didn't I? I forgot to move something. Hang on, I gotta do some math here. I have made a mistake. Where is it? Min SPIFFS. So this is the original SPIFFS file that I was using. Well, the CSV file that I was using. So I'm going to just take that, paste it down here. Now, I have moved this quite a bit. So from 1E down to 8907. Okay, so 7. So this should be what's 7? What's 1F minus 7? It should be 8. Yeah, 9, A, B, C, D, F. Okay, and I'm going to keep that the same size. So this one should actually be down from 3D. Should be 128, I think, right? No, 38. 8, 9, A, B, C. No, 8, 7, 6, 5. 6. Yeah, that's straight. Yeah, okay. That should be the right one now. Let's try that. Now let's just put some numbers in here. Sorry, I was quiet there. I was just trying to. Maybe that's why I'm getting confused. I keep talking while I shouldn't be talking. So this is SPIFFS. And the program space is, yeah. This is the original. Come on, we use the right keys. Original min spiffs.csv file contents. I just want to make sure I keep a track of what I'm doing here. All right. Okay, so let's save that. And now we'll copy it over to this folder as soon as I go find it again. Nope, not that folder. That folder. Oh, boards.txt. Do I have to update this? Yeah, I should update that. Program space is this. And we'll call it 1.5 and a 220. Okay. So let's close all this stuff Close Arduino. I don't have any, yeah, I do have an Arduino open. Let's open it all back up. Let's just do the file system first and see. Oops. Data. Okay, so all of the files are in fact there, so that's good. Let's check our partition scheme. Yeah, we'll see if this works. Tools. It did not work. Where? Oh. Why did that get smaller? Oh, that should have. Size 220. Why? Why is that not enough space? I don't even know if I can actually. Let's just compile this and see what happens. But I don't know why I'm running it. Those files do not take up that much space. There's more than enough space. There is more than enough space available for those files. Huh. I wonder if I'm still doing something wrong in this CSV file. Maybe some of these numbers aren't quite right. But it might all be for naught anyways. There's other ways around it, I think. So what I'm going to do is I'm actually just going to start adding the Arduino OTA code from one of the examples. Why did you crash? Oh. Look at that. Cool. So that one, I think, put in the wrong spot, 8, 9. Okay, let's try that again. I have to take this and copy it over. And I think I have to restart VS Code to make it all take effect. And then we'll do another build. Wow, that takes time and effort, eh? All right, well, you know what? So while that's building, you go ahead and keep an eye on that. I shall be... Was I getting really weird sound? Nobody's telling me, because I think I just realized I had 2 microphones on, so that must have been weird, right? Was that not weird? It didn't work. Why didn't it work? Okay, I think I was doing something wrong there. Probably still doing something wrong there. But let's find out. Take that. Take that. Open that. Open this. Oh man, a lot of going on here. Okay, so let's see if I can build this now. Well, let's see what happens here first. Okay, I've got it selected. Yeah, still won't fill. Interesting. Oops. What is the wait, what's going on here? Did I do something bad? I've done something bad, haven't I? Ah, I don't think it actually matters, but whatever. There. We should put the header back. Whoops, maybe that blank line was causing problems? Who knows? It shouldn't be. Anyways, let's see if this builds. Just make a copy of this into my notes. SPIFFS data size is 36. Why isn't that enough? 221K. 221 bytes. That is enough. SPIFFS size. Why does it say 216? And all my files are only 100. 166 kilobytes. So when that's full, it's even only 180, 170 kilobytes, 180 kilobytes. I have enough space. There should be enough space. That works. Well, you know what I'm going to do? I'm going to go ahead and upload this code, and you know what? I'm going to go ahead and upload this code and just see what the hell happens. Now it's not going to work because it doesn't have a configuration file, and it's not. Oh, I'll plug it all in. Okay, so while it compiles, it's going to ask, when it reboots, it'll do the display calibration routine, and then it'll hang on the splash screen with the network and server information being empty. Okay, so here we go with the upload process. So when it restarts, it should be looking at the Dft calibration screen. Oh, what's going wrong here? That should be looking at the Dft calibration screen. Go into the Bluetooth screen. Nothing. It's not working at all the way it should be. And looking at the oscilloscope, what the hell's going on there? Okay, well, let's flip this back. To Huge App. Rebuild it and upload that. So I just switched my board config back to the Huge App partition scheme, and I'm going to rebuild and re-upload with that. So that should give me the calibration screen when it restarts, because obviously I've done bad with my own CSV file. Something's not right there. Yeah, and look at what that oscilloscope is doing. It's just measuring, I don't know what the hell it's measuring. Excuse me. So this will take a minute to load up. What's going on here? Huh. I wonder why I can't get that partition scheme to work right. Inquiring minds would like to know, why isn't that partition scheme working? It really should be enough. You know what, I'm going to try a couple other things. Just in Arduino IDE without, where is it? There it is. So I'm just trying to build this with the Huge App, the same partition scheme I have been using. We're going to start Arduino, and I have to use this to actually do the upload of the file system, because for some reason the option doesn't exist. Okay, if you look at down below, we are connecting. So I need to push the button. There, that's loading up. I need to use this to actually do the upload. I want to use Huge App. Good. So when this reboots, it should just get hung on the splash screen. There it is. Well, that was interesting. See, the file system remained untouched. When I uploaded that last code with the new partition scheme, that should have blew away the file system and made this, no, this shouldn't, something's not right. That should not have worked. That means that means none of my changes are affecting the size. Here. The hell? What do we got here? SPIFFS 1.57. I need another small SPIFFS. 190. That is too small. But what is this? 1.5. What else do we have? I gotta find a different one that'll work. Minimal. What is minimal map to? Let's have a look at what this one looks like. Might be able to do some interesting work with that one. Here, this one. So this is what that one looks like. And this is what that one looks like. Hang on. I'm going to close that just so I don't do bad things to it. Just open up a new one. So this one was min, right? Yeah. Min SPIFFS. Okay, and this one was called minimal SPIFFS. That work. I'm confused about what's going on here. Whoops. Okay, so E89, yeah. Yeah, 37 is right. And 36 is right. That should be right. But why isn't that big enough? Why is Arduino complaining that that's not enough? Why is it saying it's full? It's not full. Let's try minimal SPIFFS, because I get the same problem with this one. See? File system is full. 190. size, 192, yeah. See? But I don't know what to do about that. It's just what's the next smallest one? Huh. Well, you know what? Let's just have a look around and just see what we can find. ESP32 partition with SPIFFS OTA. Let's see if anybody else has some examples we can use. Nope. Definitely too big. I'm using, yeah. Okay, no help there. No, that was not going to help. Just looking for some examples that'll give me a go, because I don't know why I can't get that, why it's saying it's full. What else have we got going on here? What's going on here? So this is using, yeah, the other way. But I just want to figure out what some of these numbers are. This is I/O bits, customizing ESP32 partition tables. I think I've seen this site before, but nothing useful here. Yeah. Nothing there, nothing there. I don't know why it's not big enough. It's driving me nuts. So I could probably, I'm going to try remaking these fonts. There's something I might be able to do there. If I go back to home, there's another text file in here somewhere. Where is it? Software, ESP32. Processing font settings. So I wonder if I need all of those fonts. Let me just see here. Let's see if I can still do this. It's been a while since I've done this. I've got copies of the original. I'm going to remake all my fonts, and I'm actually going to remove some stuff and see if they still work. This will be interesting, but my goal is just to make them smaller. I'm going to do that by removing some of the character sets that I'm not really using. So I'm going to open up processing, and I have this sketchbook, this sketch here somewhere. Yeah, this one. Okay. shoot. Okay, so I think that's right. So I'm just going to, this is processing. This is, you're probably familiar with processing. If not, it's actually pretty cool. Go check it out. But this is how I created the fonts. This is just an empty script. You need at least some sort of script to have open, so it's an empty script. But if I go to Tools, Create Font, there's this pop-up box. Now the fonts that I'm using in this are called SCG, those ones. And let's start off with the 18-point font. Go to Characters, and now that's where this image comes into play. Where'd it go? Get rid of this. So in my GitHub repository, you'll see this processing font settings. Basic Latin, it says specific Unicode blocks, Basic Latin, all of those. I don't think I need this one, Latin B. So I'm going to remove it. We can find out what's going on. Now I might have to do some experimenting here, but I think I can get these font files down in size by removing some of these character sets that I'm not actually using. So let's see, now where am I saving this to? I want to click OK, but I don't know where it saved it to. I don't know where my processing working directory is. I think it's one of those app data folders. Nope. Oh man. Well, let's go to Tools, Edit, File, Preferences. Okay. So I just have to figure out where my working directory is. There it is, for creating fonts for data. Oh, there we go. So I've got a lot going on in here. I'm going to back all this stuff up. There. Now I'm going to do this again. Tools, Create Font. But this time I'm actually going to remove Latin B. Okay, so where's my text file? I'm going to create a new file here just to keep track of what I'm doing. Font text. I am replacing Segway 18. New font set. Just going to copy those in here. Basic, Latin, Latin 1, supplement, and Latin EXTA. So my goal just bear with me while I pull out the right folders for you to look at. Everything is everywhere in Windows. You can never put everything where you always want to put it because it's always got to be somewhere else because it's what's in Windows. Oh, I hate Windows. No, I'm just kidding. Okay, finally found it. There we go. So I'm going to replace this file that's 78 kilobytes, and I'm going to see if I can create a new file that still has all the characters I need, but it is smaller. Okay, so click OK on that, and then click OK here. That will create my new file. It'll take a minute to build. You can see it's growing in size. Now, I already have backup copies of these files, so if I blow something up, I can always replace them easily enough. See? Okay, I think that worked. And that new file is only 43K. Wow. But that's an important font file. Let's go see if it actually works. So I'm going to replace it with a new one that's even smaller. And now let's do the same with a 14 sized font. It's got to be the same character set. No extended B. Wow, so that saved me a lot of size on that 18 size point font. Now let's try a 14 point font. The size to beat is 54. Okay, new size for my 14 is 30. I hope that works. And then let's do a 10 point font. It says using the new character set. So the HardSense actually does use some special characters in it. I'll show you. But not a lot. And I really wasn't careful when I came to make these fonts. Oh, wait a minute, we finished. So the new 10 point font is 21K as opposed to the original 37. So that's made those significantly smaller. So 93.6 kilobytes down from 160 kilobytes. But we got to see if these fonts are actually going to work. So some of the special characters are just simply the degrees C and the percent sign. So I shouldn't really need all of these extended fonts. So let's see what happens when I upload the new font sets. I'm going to switch this back over to the actual scheme I'm using, which is Huge App. Now, uploading these files is going to blow away the Dft Calibration. So when this reboots, I'll have to go through the recalibration. And it's going to blow away the HardSense, so I'm going to have to reconnect and update all the settings again. And that's fine, it's supposed to work that way. So let's do this. I push the button over here. Actually, you know what? Wait. All I did was I replaced the files. I didn't replace any code, so this should just work. Right? Did you upload? Did you upload? Are you finished uploading? Are you done? Doesn't look like it. Oh, I did. Okay. I just had to reboot it myself. So now we're on to the touch screen. Let's get a close-up look at what's happening here. Touch there, touch there. Now, okay, good. Now we can see on the oscilloscope it's doing some regular updates for the circle. Should be updating about every 15 milliseconds or so. Now let's go into Bluetooth mode. Now we gotta go ahead and upload new settings, and hopefully it doesn't crash, because I think I've got a bug in here as well. Settings, Bluetooth configurator, connect. So it all connected, that's good. Those are the right numbers. I need to change this to AERIE and 4121. Update it. Good. And it didn't crash. That's a bonus. This is star sign. And I have to go get the password. Forgive me. Oh, pardon me. What's going on here? Sorry, I'm just digging up the password to type into that screen. I don't know what you call those networks that are just for sort of internal testing. Okay, paste, paste. Now we should see data get refreshed on here? No? Why? Try that again. It's not updating those particular values. Why? Well, let's just reboot it and see. I think it might still be. This is, I think, where that underlying problem is coming from. That's giving me an issue. So it did do a partial update. There we go. Now it's all updated properly. Good. Let's reboot this. Now we should see if the fonts are working everywhere. Look for everything. Everything is looking good. Now the 18-point font is the bigger font, so this is all. This screen uses all 18-point font. All right, so this looks good. Let's go to the CPU screen. Or not. There we go. All of the text is displayed there, the degrees Celsius and the percentage. That's good. 3930K, that's good. Let's go over to the GPU screen. This screen uses smaller fonts, 12-point and or the 14-point and the 10-point fonts. There we go. And everything is good here. Degrees Celsius, percentage, all the text is displayed. All right. I do believe I have done good. I have actually reduced the size of my font file significantly. So you know what? Let's go ahead and see if my new font file, if the new files will actually compile into this minimal this minimal partition scheme. It does. So I think I just solved my problem that I could have just spent the last 2 hours trying to figure out. I fixed it just by paying attention to my fonts. Awesome. So I don't have to make a whole custom partition anymore. I can just use oops, nope, not that button, this button. So I'll have to make some notes, but yeah, it looks like I can actually just use this one, minimal SPIFFS. So I'm going to go ahead and recompile with this. Watch this. This is going to work. Oh, that was the wrong freaking button. Oh my gosh. So I'm going to recompile with this new partition scheme. So I am now using the minimal SPIFFS. So a 1.9 megabyte app. So that's a lot of space for my app. This has OTA. It has that OTA space. And 190 kilobytes for SPIFFS, which is more than enough, because this all comes to 93 with the additional files. I'm looking at barely over 100. So yeah, I have more than enough. So you know what? This is going to compile just fine. I need to use Arduino to actually do the upload. So let's set this minimal SPIFFS. I've chosen the right one. I have an idea. I have an idea about what I'm going to do now. Oh my God. Why didn't I just check the damn font sizes to begin with? Incredible. So I'm still waiting for this to load and compile. It takes forever. You know, while we're waiting, go ahead and click one of those links down below, or to subscribe, turn on global notifications. The next step in this is to actually make a circuit board. So hopefully we'll be doing that over the weekend. I think we're ready to go. Now, when this reboots, it should be at the TFT calibration screen, because it should have blown away the SPIFFS file system. It should have blown away those files. It'll reboot. It'll have the, there it is. What I need to do now is upload all of the raw files from here. Writing. So this is what I expected to see. So good. Now we're back here. I can do my TFT calibration. Now we're onto the network screen, which should be blank, which is fantastic. Now what we want to do is go to HardSense, Bluetooth configurator. We'll connect to it. Hopefully. No, of course not. I'm not in the, that's not going to work. I got to go to the Bluetooth configurator screen. So press and hold the button. When this button is held down during startup, it detects it as you want to go to the configurator screen. So this is what I call the Bluetooth configurator screen, if you're new to this. This screen is where I can actually connect from the HardSense application. I can go to settings, Bluetooth, and this is my Bluetooth configurator, and I can actually update all of that information remotely. As you see here, we have SSID, name and ports, device IDs. All of that information can be updated remotely. This screen is also where I'm going to put the OTA update. So there'll actually be a nice little button on here that I can press. They'll say, okay, go into OTA mode. And then I can actually do an OTA update. It's going to be cool. It's going to be really cool. But for now, let's just I got to update all the settings. So let's go have a look at what's going on. So I've just connected with the Bluetooth configurator on that port, and it's telling me that all the information is empty. Yeah, there's some display bugs, whatever. What I need to do first is just, where is it? There we go. The SSID is star side. The password is unknown to everyone. Press the update. It didn't update. I have been having a little stability issues. I think probably because when I'm streaming, I'm not really paying attention to everything, and I'm introducing bugs where I shouldn't be. Come on, just give up already. Let's see here. Yeah. Uh-oh, I think it might be hung. Now this isn't my fault. The actual underlying Bluetooth driver can do weird things, and it really annoys me. And yeah, it's actually done one of those weird things, and it's really blown up. Oh, you suck. Son of a... It's dead. There we go. Thank you. Good. Now let's just actually restart it. Okay, now I'm just gonna, just for S's and G's, unplug this. So I've unplugged the Bluetooth. Turning it off just to see what's going on. We can see my oscilloscope's gone down to 0. Turn it back on. Okay, so there's no network or anything. That's good. Rebooted into Bluetooth mode. There we go. Come back over here. Nope, not that screen. We will connect with Bluetooth. There we go. Nice successful connection. Type in the secret information. Click update. It crashed, but it did update and save it. But the crashing part wasn't good. I do know why it's doing this, and it's because of the file system is being accessed by both the serial object and the text printer sprite. And when the serial object saves its settings, it causes a conflict. Okay, so that's been updated successfully and it didn't crash. So that's good. Okay, so we should be good there. I can exit here. When I reboot, it should successfully connect. All the colors look good, all the text looks good, all the symbols are there. Let's go to the GPU screen, or the game screen. Again, everything looks fantastic. Let's go to the CPU screen. Come on now. There we go. All the symbols are there, everything looks good. Now, this took up, perfect, 138, 70% of the program space. So I have more than enough space to actually do what I need to do now. So you know what I'm going to do? I'm going to do this. I'm going to do this. I'm going to close this. I've got my new font sizes that are all beautifully done, but I'm going to pop over. Okay, in my README file, I don't need any of this anymore. This is all just random data I don't need. Let's get rid of it. There. All the way up to there. This I'm going to take out. Where's my boards.txt? It should still be up here. I don't need that. Don't need that. Don't need that. Don't need this. I do need this. Okay, where is my minimal SPIFFS? It's this. I'm just going to copy this. Put it in here. Minimal SPIFFS. Upload is that. Stick that in here. I'm going to take those 3 lines. I'm going to copy them into my README. So that one's happy. I'm going to close that. I don't need this. That's something else altogether. I don't need that. What I do need to do now is go back into here, open up this folder. So much weirdness going on. Alright, now, here's what I'm going to do. That min SPIFFS, this is the one that's been successfully, just successfully used everywhere. I'm going to go ahead and I'm going to open it up, and then I'm going to open up my local version of my own CSV file, and I'm actually just going to copy the min SPIFFS in its entirety into mine. Just full attribution is given everywhere in the README file. HardSense is based on this, which can be found in the defaults. Is a good starting point. So yeah, I'm only doing this so that I can have actually something that goes with the project. It can be checked in and tracked, and people can build with that particular partition to make sure everything is going to work the way we expect it to. Okay, so now that I've got my local copy of that, I'm going to go over here and paste it in. Good. Now, everything is saved. Yeah. I don't need this anymore. I'm working on that. That's saved and copied. Yep. This is just something else I've been working on. Okay, so there's that. So now what we can do is I'm going to close this, close the Arduino. I'm done with the processing with my fonts. I got to change that picture. Oh shoot. I got to change that picture. I got to do that before I forget. If I don't, things will be bad. So what I'm going to do is this. I'm going to open processing again. It just takes forever. I'm going to open up my my sketch, which is called for creating fonts, and that opens up a whole new window over here. Tools, create font, which opens up over here. Characters. I'm going to change this. It still opens up over here to specific Unicode blocks, basic Latin, those three. Take a picture of it. And then open up this. There, that's the new picture. Select, crop, save it. Okay, so that picture will update. This picture will update in the GitHub repository with the new one when I check it in. Let's open up VS Code again. Let's set the new partition that I just created. It's called the HardSense partition. It's just based off of that minimum one, but it's now HardSense, so the name is consistent everywhere. And yeah, good. And I'm sure we can build with it. And while that's building, let's just open up the Arduino IDE itself. Takes its time. Takes its time. It really takes its time. Thank you. So this is my HardSense project. You know what? Let's just have a quick look. Data. So those are definitely the smaller files, and they're not checked in, so that's good. We'll just do this. Make sure my right partition is selected. HardSenseESP. Yeah. We'll push this. Yes. Good. It worked. Now, the upload failed because the cable's not plugged in. Over here, you'll see that if you look below, it's not plugged in, which is good. But now I have to go plug it in. It did compile. Everything is wonderful. Now I have to plug it in so that this works. No, I'm actually just doing a verify there. So I don't need to worry about this. It's just doing a verify. But it's just pinned to CPU. Wow. Sorry, my camera's bouncing, isn't it? We can see the oscilloscope is doing its thing. And it's still verifying. Still taking its time. And it's still not done. And it's still not done. Oh, it's done. And good. Those are good numbers. Those are really good numbers. I am so very happy. So you know what? Let's make sure everything is saved. I don't know what this is. I don't need that. Everything else is saved. Let's just check this into the branch. Or push it, I mean. New font files are smaller. That's good. That fixed a lot of problems right there. Commit and push. So we're still working on branch 18. Take a look at the new processing. So now you can see, yeah, I turned off the LED and extended B. So that fixed it. That's good. Everything else is good. We have a look at our HardSense partitions. Yeah. Wonderful. Absolutely wonderful. A lot going on in the world of YouTube and stuff, so. Okay, well that was a lot of work for what turned out to be a ridiculously simple solution. So working with I don't know why, I really don't know why it wouldn't accept those file sizes though. And why it kept saying full even though there was more than enough space. It's very sad and annoying. Very disappointing on what's going wrong there. Anyways, so the next step is actually add the OTA code, and I'm going to use a one of the examples and just stuff that in, and it'll actually work quite well. I've already had a quick look at it. So if we go into the Arduino examples for the ESP32 dev module, boom, Arduino OTA, basic OTA. That's all I need. This is already using the Wi-Fi serial object, so that's part of my serial class. And then it's just got this little bit, but I don't know how much memory and program space it'll take when I actually build this in. So that's really all that you got to do. And this will give me over-the-air update capabilities, I guess. So this is something we're going to continue on a little later. The stream has gone on long enough with very little accomplished. So thank you all for watching. You know, that oscilloscope is actually doing something useful. It's really interesting. It's showing me all the updates. It's connected to the chip select of the TFT, so every time the ESP driver, Bodmer's TFT ESPI library, does an update to the TFT, it has to pull that CS pin low, and that's what we're seeing on the oscilloscope, is all of those updates is when that library pulls the pin low, says update this, and then pulls it high to continue on. So yeah, lots going on. Pretty cool. But I think we've got accomplished enough for today's session. So I'm going to wrap it up. We'll come back a little later and we'll actually finish this bit. This stream turned out to be a bit of a dud. Oh well, it happens. The next one will be much more interesting. We'll do a lot more programming and we'll see how it goes. So anyways, thank you all for watching, and I will see you all my next stream later on, or maybe we'll play some Black Mesa. Anyways, thanks. Don't forget, we will be making a circuit board soon. Once we actually do the OTA code, the next step is to finish off the circuit board. And that's my goal for this weekend coming up, is live streaming the entire process of making my own double-sided circuit board to support this project right here. Lots of stuff going on there. Okay, so thanks again for watching, and we'll see you soon.
Shut up and sit down.